Bismillahirrahmanirrahim. As you know, we were discussing the period 3 elements. Today we discuss the physical properties of period 3 elements. As you know, the period 3 elements, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. We will describe the oxides, period 3 oxides. Now this is Na2O, the oxide of sodium, MgO, Al2O3, SiO2, P4O6, P4O10, SO2, SO3, Cl2O, Cl2O7 and it does not form oxides. पीरियड 3 एलिमेंट जो हैं, जैसे आपको पता है कि ये शुरू होते हैं सोडियम, दी नॉर्मल ऑक्साइड, सोडियम ऑक्साइड, मैग्नीशियम ऑक्साइड, एल्यूमिनियम ऑक्साइड, सिलिकॉन डाइऑक्साइड, फास्फोरस ट्राइऑक्साइड, सल्फर डाइऑक्साइड, सल्फर ट्राइऑक्साइड्स. These oxides are highest oxides. It means that the element that all the electrons are utilized, all the electrons are utilized in the bond formation. That is, for example, sodium uses 1 electron, magnesium uses 2 electron, aluminium 3 electron, silicon 4 electron and so on. So in fact these oxides are the highest oxides in the way that all the electrons are utilized in the bond formation. Now we describe these, the structure of oxides. The structure of oxides, there are 3 types of structures. Number 1, metallic structure, joint ionic structure, that is the sodium, magnesium and aluminium form ionic solids. Ionic solids, joint covalent structure, joint covalent structure, they are covalent oxide like silicon dioxide. And number 3, molecular oxides like SO2, SO3, etc. So in fact the metallic oxide, these are the ionic, giant ionic oxide, that is in the form of sodium oxide, magnesium oxide, etc. These are in fact the metallic. Number 2, the giant covalent like SiO2 oxide containing silicon bonded with 4 oxygen atoms like this. Whereas in case of molecular oxides like sulfur dioxide, sulfur trioxide, in sulfur dioxide 4 electrons are utilized by sulfur atom. In SO3 all 6 electrons are utilized. So we can say, if we explain the structure of oxide, metallic oxide, giant ionic oxide, giant covalent oxide, molecular oxides. Now we will discuss the melting, other physical properties, the melting and boiling points. As you know that the oxides of period 3 elements, their bonding basically is different in different oxides. The sodium oxide, magnesium oxide and aluminium oxide, these are the ionic solids and they possess strong bonding. So therefore the melting boiling points, they increase from left to right up to the silicon dioxide. The joint structures possess high melting point and boiling points due to strong ionic and covalent bonding. चूँकि इनके दरमियान जो ऑक्साइड्स बन रहे हैं, बेसिकली सोडियम ऑक्साइड, मैग्नीशियम ऑक्साइड, aluminium oxide and silicon dioxide, they possess giant ionic structure. They possess high melting and boiling point, means that the melting point and boiling point increase from left to right up to the middle, and this basically is due to high melting points and boiling points due to strong ionic and covalent bonding. The oxides of sulfur, phosphorus and chlorine. Sulfur, the oxide SO2, SO3, P4O6, P4O10, and this Cl2, Cl2O7. So this is chlorine 1 oxide and this is chlorine 7 oxide, heptaoxide, or this is dichlorine oxide, this is dichlorine heptaoxide. Now these all oxides consist of individual molecules. Their melting point and boiling points are relatively low due to weak van der Waals interactions and dipole forces. लिहाजा यहाँ हम ये कह सकते हैं बुनियादी तौर पे कि जो फर्स्ट ऑक्साइड्स हैं, जैसे सोडियम ऑक्साइड है, मैग्नीशियम ऑक्साइड है, एल्यूमिनियम ऑक्साइड है, सिलिकॉन ऑक्साइड है, इनके जो मेल्टिंग बॉइलिंग पॉइंट्स होते हैं, ये इंक्रीज करते हैं फ्रॉम लेफ्ट टू राइट अप टू द मिडल बिकॉज ऑफ दे पोजेस हाई मेल्टिंग एंड बॉइलिंग पॉइंट्स इन जनरल ड्यू टू स्ट्रॉन्ग आयनिक एंड कोवलेंट बॉन्डिंग. Whereas the oxides of sulfur, either in the form of sulfur dioxide or sulfur trioxide, phosphorus P4O6, phosphorus trioxide, phosphorus pentaoxide, chlorine, it forms different oxides, but here Cl2O, that is chlorine 1 oxide or dichlorine oxide. Similarly Cl2O7, chlorine 7 oxide or dichlorine heptaoxide. So these basically consist of individual molecules. The melting boiling points are relatively low due to weak interaction dipole forces and tend to be gases, liquids. Now we come to another physical property of these, that is electrical conductivity. None of these oxides conduct electricity due to no free electrons. कि ये जो बेसिकली ऑक्साइड्स हैं, इनमें आम तौर पे ये बिजली कंडक्ट नहीं करते इन सॉलिड स्टेट, और जब ये सॉलिड स्टेट में होते हैं तो उनमें फ्री इलेक्ट्रॉन्स नहीं होते, लिहाजा ये आम तौर पे बिजली नहीं कंडक्ट करते, बट कंडक्ट इलेक्ट्रिसिटी ओनली इन मोल्टन स्टेट. मोल्टन मीन्स लिक्विड या मेल्टेड molten state, because in molten state these are converted into ions. Basically the ions act as carrier of electricity. So in general तो आप कह सकते हैं कि बुनियादी तौर पे ये जितने भी ऑक्साइड्स हैं ये बिजली कंडक्ट नहीं करते in the solid state, but they can conduct electricity in the molten state, that is either in the liquid form or in the melted, means another, you can say in the liquid form, because in molten state these are converted into ions which act as a carrier of electricity. Their movement, that is their movement towards electrodes, causes flow of electric current. So in general, once again, electrical conductivity, as you know, this is the property of the different substances or their capability to conduct electricity due to the movement of free electrons. जैसे आप सब पता है कि free electron basically उनको हम कहते हैं which are away from the nucleus, their valence shell is away from the nucleus, or there is a large shielding effect. Shielding effect means the number of underlying shells in between the valence and the nucleus, they are in large number. So those electrons in the valence shell, they become free from the nuclear attraction and they can move freely. Since in solid state there is no availability of the, क्योंकि इसमें free electrons available नहीं होते, और free electron बेटा वही होते हैं जो बुनियादी तौर पर न्यूक्लियस से काफ़ी दूर होते हैं. अगर ये आपका न्यूक्लियस है एंड ये डिफरेंट शेल्स हैं, तो अगर यहाँ पे एक इलेक्ट्रॉन है तो लिहाजा ये एक फ्री मूवमेंट शो कर सकता है. लेकिन अगर इसमें आपका जो इलेक्ट्रॉन है वो न्यूक्लियस के करीब है, तो यहाँ जो न्यूक्लियर अट्रैक्शन है वो इस पे काफ़ी स्ट्रांग होती है, लिहाजा सॉलिड फॉर्म में फिर ये बिजली कंडक्ट नहीं करेगा। लेकिन अगर इनको मेल्ट कर दें या सोल्यूशन फॉर्म, दे आर कन्वर्टेड टू आयंस, आयन बनेंगे। जैसे सोडियम क्लोराइड है, सॉलिड फॉर्म में है, बिजली कंडक्ट नहीं करेगा, लेकिन अगर आप इसको, या सोडियम ऑक्साइड है, तो जब ये आयनाइज होगा, आयंस बनेंगे, तो फिर ये इलेक्ट्रिसिटी कंडक्ट कर सकते हैं। नाउ वी डिस्क्राइब अनदर फिजिकल कैरेक्टर्स और द अदर फिजिकल बिहेवियर, that is acid base behavior of oxide. Acid base behavior of oxide. Now if we consider the period 3 elements, this is strongly basic, this is basic, this is amphoteric, this is weakly acidic, this is acidic, strongly acidic, most strongly acidic. Now in general the oxides are maybe of metals or the non-metals. Know that the sodium oxide, which is normal oxide, is strongly basic. Magnesium oxide is also an oxide of alkaline earth metal, is basic. Aluminium oxide is amphoteric, means it can behave as acidic and basic. The silicon dioxide, this is group 1A, 2nd A, 3rd A, 4th A, 5th A, 6th A, 7th A, 8th A are 0 group. So you can say in the basicity, the basic character increases, decreases from left to right, and the acidity increases from left to right. Now the basic character decrease from left to right, that is the sodium oxide is more basic than magnesium oxide. Similarly, the acidity increases from left, especially from silicon to chlorine heptaoxide, means that Cl2O7 is more acidic than silicon oxide or other oxides of non-metals. The behavior of oxides of period 3 elements. Now the oxides of period 3 elements are sodium oxide, magnesium oxide, aluminium oxide, silicon dioxide, phosphorus oxide, trioxide, pentoxide, sulfur dioxide, sulfur trioxide, Cl2O, Cl2O7. These are the oxides of period 3 element. This is strongly basic, this is basic, amphoteric, acidic, strongly acidic. So this is the behavior of the oxides. That sodium oxide is a strong basic character. Similarly, magnesium, this is amphoteric, means that it behaves as acid, as a base. Now today we discuss the reactions of oxides of period 3 elements. Period 3 elements, that how the oxides, the reactions of oxides with water, acids and bases. Now हम ये देखेंगे कि किस तरह ये जो डिफरेंट ऑक्साइड्स हैं, वेदर दे आर स्ट्रांगली बेसिक, एम्फोटेरिक और एसिडिक, हाउ दे रिएक्ट विद द वाटर. सो वी विल डिस्कस वन बाय वन. नंबर 1, that is the sodium oxide. How this sodium oxide react with water? It reacts with water being a strong base with the evolution of heat, that is exothermic. Its behavior is exothermic. So Na2O plus water gives NaOH. Being a strong base, it reacts with acid HCl, that is Na2O plus HCl gives 2NaCl plus water. this is balanced. Similarly, the magnesium oxide is simply a basic oxide and dissolves in water to produce MgOH twice. Magnesium oxide is also basic, although it is less basic than sodium oxide. MgO plus water gives MgOH twice. So the reaction of the oxides, they are reactive towards water. Acids are bases. Sodium oxide is a strong base, therefore it combines with water with the evolution of heat, that is, it is strongly exothermic. Na2O plus water gives 2NaOH. Being a strong base, it also combines with the acids to form salt and water. The salt is sodium chloride. Then the magnesium oxide, which is also basic but is simply a basic oxide and dissolved in water to produce a solution of magnesium hydroxide, although it is less basic than sodium oxide due to relatively weak bonding. Magnesium oxide dissolved in water to produce magnesium hydroxide. Magnesium hydroxide, it reacts with acids to form a salt and water. To form salt and water, suppose if you take MgO plus HCl gives MgCl2 plus H2O. So this produces aluminum. The next is aluminium oxide. It is amphoteric, behaves as base or acid. Aluminium chloride, when dissolved in water, is not dissolved in water since the ions are not available. Since the ions are not available, which are held strongly. A reaction with acid, aluminium oxide reacts with HCl to produce AlCl3 salt. Al2O3 plus HCl gives AlCl3 plus water. इसका मतलब ये हुआ कि बुनियादी तौर पे चूँकि ये बेस है मैग्नीशियम हाइड्रोक्साइड, ज़्यादा ये एसिड के साथ रिएक्ट करेगा और साल्ट और वाटर बनाएगा. जैसे न्यूट्रलाइजेशन आपने रिएक्शन पढ़ा हुआ है कि जब भी कोई एसिड और बेस आपस में रिएक्ट करते हैं, they are neutralized together to produce salt and water. So here the salt is magnesium chloride and this is water. This is not dissolved in water since ions are not available which are held strongly in the lattice. The reaction with acid, that is the aluminium oxide, since is amphoteric, so it can react with acid as well as with base. ये बेस के साथ भी रिएक्ट करेगा, एसिड के साथ भी रिएक्ट करेगा. तो लिहाजा एलुमिनियम ऑक्साइड जब HCl के साथ रिएक्ट करता है तो यहाँ भी साल्ट और वाटर बनेगा. जैसे Al2O3, here it is acting as a base, so it combines with acid to produce salt and water. Similarly, a reaction with an acid with a base, it reacts with a concentrated solution of NaOH to produce sodium tetrahydroxoaluminate as represented by the reaction. Now aluminium oxide combines with NaOH to produce NaAlOH4. NaAlH4, this is a sodium tetrahydroxoaluminate. So here the aluminium oxide is acting as an acid. As you know, this is amphoteric So it combines both with the acid to produce salt and water, and here it is acting an acid with the concentrated solution of sodium hydroxide. On strong heating, it produces sodium tetrahydroxoaluminate.